What if you could witness a new ocean being born? Deep in Africa's Afar region, the Earth is splitting apart, setting the stage for a geological transformation that could redraw continents and reshape ecosystems. This extraordinary phenomenon, driven by tectonic forces, is more than just a scientific spectacle. It holds clues to Earth's ancient past and its evolving future. But what sets this process into motion, and how can we witness its dramatic beginnings? Let's travel to one of the Earth's most active geological regions to uncover the answer. Nestled in Ethiopia's Afar Desert, the Dabbahu Volcano quietly stands in one of Earth's most geologically active regions. Here, tectonic plates gradually move apart, shaping the arid landscape. In the year 2005, Dabbahu erupted, breaking its long silence and demonstrating the immense natural forces beneath the Earth's surface. Before the eruption, the region displayed noticeable changes. The ground swelled, and over 130 small earthquakes occurred within a few days, raising concern among local communities. On September 26, 2005, the volcano erupted, releasing ash and rocks into the air and leading over 6,000 people to relocate for safety. The event created cracks over 3 feet wide and a fissure stretching 37 miles, exposing molten rock below. This remarkable geological event, compressing centuries of tectonic activity into days, left scientists exploring its causes and potential implications for future changes in the region. If you lived near the Dabbahu volcano in 2005, how do you think you would have reacted to over 130 earthquakes in just a few days? Would you stay or leave? Comment and chat with me. But that was only the beginning. What followed next was an unprecedented transformation that reshaped the land and defied scientific expectations. The eruption of the Dabbahu volcano marked the start of a geological transformation that fascinated scientists. Within days, the ground split open, revealing fissures stretching 37 miles, with the largest, the Dow fissure, over 1,600 feet long. This rapid event represented centuries of typical tectonic movement compressed into days, as if the Earth unzipped a massive seam to expose its molten interior. This significant rift reshaped both the landscape and geological understanding. Experts, including the United States Geological Survey, highlighted the unprecedented speed and scale of the event, offering a rare opportunity to study tectonic processes in real time. For locals, it was a striking and memorable experience. One farmer described the sound of the ground cracking as similar to the earth groaning. The fissures were preceded by continuous tremors from September the 4th to September the 30th, ranging from minor quakes to those strong enough to rattle homes. The Ethiopian Institute of Geophysics described this seismic activity as unmatched in the Afar region, serving as a precursor to the dramatic changes that followed. Scientists continue to explore whether these events indicate a larger geological shift, such as the gradual formation of a new ocean. These questions drive ongoing research into the region's tectonic activity. But what deeper forces are driving this massive transformation? And how does a continent begin to break apart to form something as monumental as a new ocean? Could the cracks in the Afar Desert be the first whispers of a global transformation that will reshape continents forever? Ethiopia is a remarkable landscape. Beneath its dry surface, the African and Arabian tectonic plates are slowly separating. Over 30 million years, these plates have been moving apart at a rate of less than an inch per year, a pace so slow it's invisible to the human eye. But this quiet process is anything but insignificant. It has shaped incredible geological features, including the Red Sea. The Afar region lies at the meeting point of 3 tectonic plates, the African, Arabian, and Somali plates. According to UNESCO, this unique triple junction is one of the planet's most geologically active zones. The movements of these plates have created the Great Rift Valley, a massive fissure stretching thousands of miles across Africa. Here, the Earth's crust is being pulled apart, setting the stage for the birth of new oceans and reshaped continents. A major milestone occurred in 2005 when the Dabbahu volcano erupted, accelerating the separation of the Somali plate from the rest of the African plate. This often overlooked plate is slowly drifting eastward. Scientists estimate that in about 1 million years, this movement will form a new island, incorporating parts of Ethiopia, Djibouti, and Somalia. The island will eventually be surrounded by a new sea, which could evolve into a full-fledged ocean. Imagine the Red Sea's waters gradually pouring into the rift, carving a fresh coastline where the Afar Desert now lies. This isn't just a story of geological change, it's a testament to Earth's power of renewal. The Afar Desert, often seen as a lifeless expanse, is a cradle of future transformation. These visible changes are remarkable, but what do they truly mean? Could this be the first step in an extraordinary journey to form a new ocean? Before exploring, I have a special 10-second request for all of you listening. If you can help me in any way, just hit the notification bell and hit that subscribe button. It helps this channel so much, and if you do that, I will do everything I can to make this show even better for you. Deal? When fissures in the Afar region began to form, scientists initially approached the event with caution. Could such dramatic changes truly signal the birth of a new ocean? For years, this idea was considered speculative. However, an international team of geologists, led by researchers from the University of Rochester and published in Geophysical Research Letters, provided a groundbreaking revelation that tectonic processes in the Afar Rift closely resemble those occurring at the bottom of the world's oceans. Using data from seismic sensors installed after the Dabbahu eruption, researchers discovered that magma flowing beneath the rift exhibited behaviors typical of mid-ocean ridges. These ridges, such as the one running through the Atlantic Ocean, form when tectonic plates separate, allowing molten rock to rise and solidify into new crust. The Afar Rift's activity mirrored this phenomenon so precisely that scientists now refer to it as a land-based laboratory for studying ocean formation. Initially, there was skepticism within the scientific community. The scale and speed of these changes were unlike anything we'd seen before, stated one geologist from the Ethiopian Institute of Geophysics. Yet, as data accumulated, skepticism waned. Today, experts widely agree that this marks the beginning of a process that over millions of years will reshape the African continent and create a new body of water. The Afar Rift is more than a site of tectonic activity, it's a unique demonstration of how oceans form. To understand its significance, one can draw parallels to the Mid-Atlantic Ridge, where the Americas gradually drifted away from Europe and Africa. Similar forces are now visibly altering the African continent, but instead of occurring beneath ocean waters, this transformation is unfolding in an exposed landscape. Visualize this: fissures stretching across the desert, steam and gases rising as visible evidence of the molten processes below. In the Afar region, these features offer scientists an unprecedented opportunity to study ocean-forming mechanisms without the challenges of deep-sea exploration. According to the year 2016 report by the Geological Society of America, the Afar Rift provides a rare glimpse into what the early Atlantic Ocean might have resembled millions of years ago. While scientists are captivated by the Afar Rift's potential, the local communities experience these changes in profoundly different and immediate ways. In the arid Afar Desert, water is a lifeline, yet it's painfully scarce. The 2005 fissures near the Dabbahu volcano not only reshaped the landscape but also presented a remarkable opportunity for the local Afar people to adapt. Using the steam escaping from volcanic cracks, they developed an innovative method to collect water. The process was simple yet resourceful. They dug shallow holes near steam vents and constructed low retaining walls topped with branches and grass to trap condensation. This setup created a surface where steam condensed into water, dripping into the pit below. However, the water was sometimes contaminated with volcanic chemicals, making it unsafe to drink. To assess its safety, locals used a clever trick: they held a shiny piece of obsidian above the hole. If a milky residue formed, it indicated high contamination, prompting them to dig elsewhere. The sudden formation of massive fissures also posed significant challenges for the local ecosystem. Many animals, including goats and camels, were lost during the initial eruption, with some falling into the cracks as the earth split open. These animals were vital to the livelihood of the Afar people, and their loss deeply impacted families who relied on them for sustenance, transport, and trade. Additionally, the volcanic gases released during the eruption damaged nearby vegetation, further straining the delicate balance of life in this harsh environment. The Afar people, already accustomed to surviving in one of the planet's most unforgiving climates, faced a daunting task to rebuild. Amidst these struggles, however, there was hope. The fissures, while destructive, also created opportunities for scientific exploration and potential future benefits, such as geothermal energy development. To understand the future of this new ocean, we must look back into Earth's deep past. What secrets do ancient oceans reveal about the planet's ongoing transformation? Earth's history is marked by the birth and death of oceans, shaping continents and ecosystems. One fascinating example is the Mongol-Akkad Ocean, which formed over 400 million years ago during the Devonian period. At that time, Earth's surface looked vastly different, dominated by two massive landmasses, Laurasia and Gondwana, and a string of smaller microcontinents. Tectonic plate movements caused hot magma to surge upward, creating fissures that filled with water and formed the Mongol-Akkad Ocean. This ocean, now long vanished, showcased processes similar to those seen today in the Afar Rift. Just as the Mongol-Akkad Ocean began with land splitting and magma flow, the Afar Rift is slowly carving out the framework for a future ocean. Imagine ancient Earth, where thick forests lined coastlines and the air was rich with moisture, supporting primitive ecosystems. The Mongol-Akkad Ocean lasted approximately 115 million years before tectonic forces closed it, leading to the formation of new land masses. By studying ancient oceans, scientists uncover patterns that help predict future geological events. Research published in the Journal of Geophysical Research highlights the Afar Rift as an extraordinary opportunity to observe these processes in action, history repeating itself within our lifetime. Predictions from the Geological Society of America suggest that, within 1 million years, the Red Sea will merge with the Afar Rift, creating a new sea. Over time, this sea could evolve into an expansive ocean, splitting eastern Africa from the mainland. Earth's tectonic engine, driven by heat from the mantle, will continue to shape the planet, but not forever. Over the next 1 billion years, the mantle will gradually cool, slowing and eventually halting plate movements. Without active tectonic plates, processes like mountain building, earthquakes, and the carbon cycle will cease. In this distant future, towering mountain ranges will erode into flat plains, and continents will no longer drift. Volcanoes, once symbols of Earth's fiery energy, will grow silent. Without tectonic activity, Earth's surface may resemble a static, barren landscape, much like Mars or Venus. While these changes are far in the future, their implications for ecosystems and humanity are profound. If you're fascinated by the incredible forces shaping our planet, hit that like button. It lets us know you love exploring Earth's mysteries as much as we do. But as new oceans form, what happens to the land they leave behind? The answer could shape the geography of our future world. In the distant future, Earth's shifting tectonic plates might create mountain ranges as grand as the Himalayas. Research from Utrecht University suggests that the collision between the Somali and Indian plates could give rise to a sprawling, curved mountain chain in the strait between Madagascar and the African mainland. This remarkable transformation would mark a significant chapter in Earth's geological evolution. Imagine towering peaks emerging where the ocean once flowed. This isn't mere speculation, but a potential outcome of tectonic forces continually reshaping our planet. Just as the collision of the Indian and Eurasian plates formed the Himalayas, similar processes might sculpt massive ranges in areas that today seem flat and unremarkable. This transformation from the ocean floor to snow-capped peaks highlights the relentless power of plate tectonics. Mountain formation, or orogeny, occurs when tectonic plates collide, causing the crust to buckle and rise. In the case of the possible future mountain range near Madagascar, the Somali plate could gradually push the Indian plate downward, compressing rock layers and lifting them over millions of years. This slow but powerful process, driven by immense heat and pressure in Earth's mantle, is the same force that created breathtaking ranges like the Andes, Rockies, and Alps. To understand this future possibility, consider the past. For example, 400 million years ago, tectonic collisions in western Norway built vast mountain ranges that have since eroded into the fjords we admire today. These ancient events remind us that mountain building is a slow but inevitable process driven by Earth's restless plates. The future mountains near Madagascar could also become ecological hotspots rich in biodiversity. Just as current ranges are home to unique species adapted to high altitudes and rugged terrain, these future peaks might foster entirely new ecosystems over millennia. How does this process compare to the formation of other oceans and rift valleys? Let's take a closer look at the science behind these incredible transformations. The Afar Rift is not just a geological marvel, it's a natural laboratory for studying the birth of oceans. Unlike traditional ocean ridges, hidden beneath miles of water, the Afar Rift offers scientists a unique opportunity to observe these processes on dry land. Here, the Earth splits apart dramatically, revealing magma flows and tectonic movements similar to those shaping mid-ocean ridges like the Mid-Atlantic Ridge. What makes the Afar Rift extraordinary is its accessibility. Researchers can walk along the fissures, study fresh magma deposits, and monitor tectonic shifts with remarkable clarity. A study published in Nature Geoscience indicates that the rift's dynamics closely resemble those occurring deep beneath ocean floors, providing critical insights into how oceans form and evolve. This desert landscape offers an above-ground glimpse into processes typically hidden underwater. It's a place where the boundaries between land and sea blur, offering insights into how future oceans might shape our planet. The Afar Rift's unique conditions have inspired innovative scientific techniques. Using satellite imagery, researchers can measure how the rift widens over time, down to fractions of an inch. Instruments placed within the rift record seismic activity in real time, enabling geologists to predict tectonic shifts with greater accuracy. These advancements hold significant implications for understanding how tectonic activity impacts climate, ecosystems, and human settlements. This living timeline of tectonic evolution has been featured in studies by organizations like NASA's Earth Observatory, which highlight how data from this region helps refine models for predicting geological events elsewhere, from volcanic eruptions to earthquakes. The Afar region is just one chapter in Earth's constantly evolving story. What drives this never-ending dance of creation and destruction? Earth's surface is far from static, it's alive with movement shaped by the slow but relentless shifting of tectonic plates. Picture the planet as an enormous accordion, constantly expanding and contracting as the plates beneath our feet collide, separate, and slide past each other. This movement creates the majestic mountains we admire, carves valleys, and even gives birth to entire oceans. Over millions of years, these processes have rearranged continents, turning what was once an unbroken landmass, Pangaea, into the map we recognize today. According to the United States Geological Survey, tectonic plates move at a rate of just a few inches per year, about as fast as your fingernails grow. Over time, this seemingly slow motion transforms the planet's surface in dramatic ways. These continuous changes are more than geological curiosities, they shape ecosystems and impact human life. For people living near tectonic hotspots, constant tremors are a reminder that the Earth is never at rest, connecting us to these vast, unseen forces. At the heart of this movement are tectonic plates, enormous slabs of Earth's crust that float atop the molten mantle below. These plates interact in three key ways: they collide, creating mountain ranges like the Himalayas; they separate, forming new ocean floors and rift valleys like the one in Afar; and they slide past each other, causing earthquakes like those along California's San Andreas Fault. This dynamic system is driven by heat from the Earth's core, which generates convection currents in the mantle. These currents act like conveyor belts, pulling plates apart in some places and pushing them together in others. For example, the Atlantic Ocean continues to widen as the Eurasian and North American plates drift apart, while the Pacific plate is slowly shrinking due to subduction beneath surrounding plates. The interconnectedness of tectonic plates influences climate, sea levels, and even biodiversity. Research published in the journal Science suggests that the breakup of continents not only creates new oceans but also alters atmospheric circulation. These changes can bring moisture to previously arid regions, fostering the development of new ecosystems and supporting biodiversity. As we marvel at the Earth's dynamic surface today, it's sobering to imagine a future where this motion comes to a halt. What would a world without tectonic activity look like? The future of Earth's crust is tied to the heat within its mantle, the engine that drives tectonic activity. Over billions of years, scientists theorize that this heat will gradually dissipate, leading to the cooling of the mantle. As a result, tectonic movements may slow and eventually cease. Without the constant push and pull of plate tectonics, Earth's surface could become static, resembling the barren, frozen landscapes of Mars or Venus. In such a world, the majestic upheavals of mountain ranges and the dramatic splits of rift valleys would cease. The once dynamic crust might lie quiet, with its features eroded into gentle hills and flat plains. Oceans could stagnate, and volcanic eruptions, those fiery reminders of Earth's inner energy, might become a distant memory. Some scientists, including researchers from NASA's Earth Science Division, estimate that this transition could occur in roughly 1.5 billion years, long before the Sun expands into a red giant and engulfs the planet. For now, however, we live in a vibrant era where Earth is alive with movement. This dynamism not only shapes the land but also sustains ecosystems and climate patterns essential for life. It's humbling to consider that this motion, so vital to our planet, may one day fade into stillness. The cessation of tectonic activity could have profound effects on Earth's surface. Mountains, continuously built and eroded by tectonic forces, would no longer rise and would gradually wear down into flat, unremarkable plateaus over millions of years. Subduction zones, where one plate dives beneath another, would disappear, removing the forces that create deep ocean trenches and fuel volcanic activity. These changes could also influence the planet's climate and biodiversity. Subduction zones are integral to recycling carbon through the Earth's interior, a process crucial for regulating atmospheric carbon dioxide levels. Without this carbon cycle, the planet's climate might shift significantly, potentially leading to conditions inhospitable to current forms of life. From dramatic eruptions to the stillness of a distant future, the Earth's story is one of incredible contrasts. But this journey is far from over. What will be the next chapter in the evolution of our planet? If you found today's video interesting, don't hesitate to hit the like button and subscribe to my channel. Your support is very important to us. Be sure to check out the next video appearing on your screen. You're sure to love the content we bring. Please leave a comment about which country you'd like us to explore next. Thank you for watching, and see you in the latest video. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.